Hello everyone. So far we have discussed the two derivations, that is addition of a branch and addition of a link, and in today's session we will be solving the numericals. For a given oriented graph shown below, they have asked to write a matrix, that is element node incidence matrix, K matrix, tree branch path incidence matrix, and B is nothing but it is basic cut set, and C is basic loop incidence matrix. Okay, this is a given oriented graph. I have said oriented graph because the direction is mentioned in the figure. For this oriented graph, they have asked us to write a bar matrix, a cap matrix. A cap matrix, we know branch and node. Looking at the figure, you can see how many nodes are there. 0 is a reference node, 1 node, second and 3 node. So 0 first node, second node, third node. So looking at this oriented graph, there are totally 5 elements. First are branches, first branch, second, third, fourth, fifth. Okay, now how to fill this A cap matrix? Already I have discussed. So looking at this node 0, from this node 0, first branch is going away, so it is positive 1. Second branch is also going away, it is positive 1. Third branch is nowhere connection to this reference node, so it is 0. Similarly, fourth and fifth branch are nowhere having any link or relation with the reference, so it is 0. The same way, if you hold at node 1, the branch 1 is coming towards, so it is minus 1. Branch 2 is not having any relation with the node 1, so it is 0. Branch 3 is not having any relation, so it is 0. Whereas branch 4 and branch 5 both are going away from the first node. If it is going away, then it is 1. The same way, try to solve this node 2 at node 3. I will be writing directly. So once after we get this A cap matrix, I have said try to write a reduced incidence matrix, that is A. In reduced incidence matrix, I have already told we need to eliminate this reference node. If you eliminate this reference node, then we will be getting only node 1, node 2 and node 3. Rest other matrix remains as it is. Okay, now we need to do some basic calculation. By looking at this figure, we have totally 5 elements, 1, 2, 3, 4, 5. How many nodes are there? There are 4 nodes. Also we know from the basic definition, branch is equals to n minus 1. In order to calculate the number of branches in a given figure, n minus 1, n stands for node. So it is 4 minus 1. We will be getting 3. Similarly, in order to calculate link, we have formula L equal to B minus N plus 1. This formula I am writing from the definition of tree, co-tree. Refer those definitions. You will be getting these expressions. I have dictated these expressions. Okay, B is nothing but it is 3. Sorry. Okay, in order to calculate link, we have formula L equal to E minus N plus 1. E is nothing but it is element. Totally we are having 5 element minus number of nodes 4 plus 1. 5 minus 4 plus 1 is 2. So we will be getting totally 2 links. Next, draw a tree from given graph. As I have said, we will be getting totally 2 links. So how to draw a tree from a given graph? Tree means there should not be any closed loop. So can I draw tree by considering node 1, node 2 and node 3 and reference node. But whereas I have said totally there are 2 links, I'll consider now is it forming a tree? Yes, because there is no closed path in this figure. Whereas looking at this given graph, branch 4 and branch 5 both are acting as link in this tree graph. Okay. Orientation remains as it is. We have written reduced incidence matrix. I should split up this matrix into 2 components. Let me write this reduced incidence matrix as it is. Fine. So looking at this tree, we used to split this reduced incidence matrix as A suffix T means it is with respect to twig. We call it here twig divided by link. Totally how many links we can form? 2 links, that is 4th link and 5th link. So I can divide this given reduced incidence matrix into 2 components, AT and AL. Have you understood this? In the given problem, they have asked us to write reduced incidence matrix. We have written here by splitting into 2 components. Next one is they have asked us to calculate K. What is the meaning of K? K means it is tree branch path incidence matrix, which is represented as K. K equal to twigs and here nodes. Totally there are 3 nodes and twigs. Look at this figure. How many twigs are there? Means it is a branch. Here you can see there are 3 twigs. So 1, 2, 3. Row wise it is nodes, column wise it is twig. So I'll be writing this upper matrix. So this gives the matrix tree branch path incidence matrix K. We have calculated K. Now next target is to calculate basic cut set incidence matrix, that is B. Basic cut set incidence matrix B. Okay. Now again I'll consider the same figure. Node 1, node 2, node 3, reference node, this forms a tree, but whereas it is link 4 and it is link 5. So B matrix, I'll be writing total how many elements are there? 1, 2, 3, 4, 5. Totally 5 elements. How many cut set is there? How many cut set? We can form. How many branches are there? That many cut set we can form. So cut set 1, cut set 2, cut set 3. I should cut this figure. I should cut this branch. This is a tree for a given figure. I should cut this cut set 1 in such a way that this branch 1 should be cut and n number of links can be cut. So I'll be cutting in this way and I'll give the arrow mark cut set 1. This arrow should be in the same direction as that of that branch 1. So I'll be naming here cut set 1. Fill this matrix. This cut set 1, it is in the same direction of 1. So here it is 1. If I rotate this cut set 1, it is in the opposite direction to link 4. So it is minus 1. Again, it is in the opposite direction to that of link 5. So it is also here minus 1. But for no element 2 and 3, this cut set is not having any relation, so it is 0. Similarly, cut set 2, I should cut this branch such a way that this branch should cut and n number of links. So can I cut this in this way? And I'll give the direction in the same direction as that of the branch 2. This is cut set 2. Now, I'll rotate this cut set in such a way that this cut set pointing towards this node 2, I should rotate. It is in the same direction as that of branch 2. So here it is 1. And if I rotate it this like this, then it is in the same direction. It is in the same direction as that of link 4 and it is in the same direction as that of link 5. So for 4 and 5 it is 1, but whereas this cut set 2 is not having any relation with this branch 1, so it is 0. Similarly, this is not having any relation with this node branch 3, so here also it is 0. Similarly, I should cut this branch 3 and I should name it as cut set 3. While cutting this branch 3, I should cut this branch and n number of links. I should not cut here because if I cut this also, then it is cutting 2 branches, which is false. So I should cut only one branch, that particular branch where cut set 3 I should cut, and n number of links. I can cut 2 links here, but I cannot cut this branch also. And I'll give the direction. This also should be in the same direction as that of branch 3. I'll name it as cut set 3. Look here, this cut set 3 is not having any relation with the branch 1 and 2. So it is 0, 0. But this cut set 3 arrow is having in the same direction of that of branch 3. So it is 1. And this cut set 3 is not having any relation with the node link 4 and 5. So here also it is 0, 0. You may ask, sir, it is cutting link 4 and 5, but why we are writing this 0, right? So this cut set 3 is with respect to this node 3. So this direction, this arrow mark should be pointing towards this node 3 and you should rotate it. If I rotate it in this way, then this cut set 3 is not having any link with this 4 and 5. Hence, here also it is 0. Similarly, I should cut this basic cut set incidence matrix into 2 components. BT by BL. BT refers to basic cut set matrix of with a size T, means that means number of twigs, basic cut set matrix with a size L. Looking at this figure, how many twigs are there? 1, 2, 3. So 1, 2, 3 are the twigs. I will be splitting up this matrix into two components, and 4 and 5 are the links. So here you can see 4 and 5 both are the links. So we have written the matrix for basic cut set incidence matrix. Now next target is to write the basic loop incidence matrix, that is C, for a given figure. Basic loop incidence matrix represented as C. They have asked us to write the matrix C. So matrix C, again I'll consider the same graph. Okay, from a given question we have framed a tree. We have named it as node 1, node 2, node 3, reference node 0. These are the two links, link 4 and link 5. Okay. Now C is a matrix, basic loop incidence matrix. How many elements are there? 1, 2, 3, 4, 5. Totally there are 5 elements. 1, 2, 3, 4, 5. Though these are the branch and these are the links, but totally all together are called as an elements. So here I will be writing elements, and here I will be writing loops. We know that in basic loop incidence matrix, how many loops can be formed? If depending upon the number of links. How many links are there? 2 links. So there will be 2 loops. I'll start from reference 0. This is a first loop, and I should give the arrow mark such that in which direction that link is there, the same direction I should give. I'll name it as L4, means it is loop 4. Similarly, I'll write here L4, means it is loop 4. Loop 4, it is in the same direction as that of branch 1. So I'll write it here 1. Loop 4 is it is in the same direction as that of link 4. So here also it is link 4. Link 4 it is 1. This loop 4 is having opposite direction to that of branch 2. Here it is -1. This loop 4 is not having any relation with this node 3. So it is 0. Similarly, it is not having any relation with this. This is not having any relation with the branch 3. So it is 0. Similarly, this is not having any relation with this link 5. So it is also 0. Now, one more loop can be formed from reference point. So this direction should be in the same direction as that of link 5. I'll give the direction like this, and I'll name it as link 5. Loop 5. So here also it is loop 5. Now look at this loop 5. Correspondingly, you should look at all the elements. Loop 5 linking to element 1. Loop 5, it is in the same direction of element 1. So it is 1. Loop 5 element 2. Loop 5, which is coming opposite to that of element 2. So I should write here -1. Loop 5 with respect to element 3, it is not having any relation, it is 0. Loop 5 is not having any relation with this link 4, it is also 0. But loop 5, it is in the same direction as that of link 5. So it is 1. Is that okay? So in the question they have asked us to calculate reduced incidence matrix, and tree branch path incidence matrix, basic cut set matrix, sorry, it is K, reduced incidence matrix denoted as A, tree branch path incidence matrix K, basic cut set matrix B, and basic loop incidence matrix C. All the four matrices we have calculated. So in this way the question will be asked. They will give the figure with the orientation, and they will ask us to calculate some incidence matrices. Is that okay? Now I will be giving one assignment question. You try in your home. Okay. Second question. For the oriented graph, shown below, write bus incidence matrices A cap, comma A, K, B cap, C, and C cap. All the basic incidence matrix they have asked. This is bus number 3. It is bus number 4. Here it is bus number 1. Here also it is bus number 2. From 1 to 2, from bus 1 to 2, branch 1. From bus 1 to 3, it is branch 2. From 3 to 4, it is branch 3. From 4 to 2, it is branch 5. Again from 1 to 2, there is a one more branch, second branch. Sorry, it is a fourth branch. Branch 1, 2, 3, 4, 5. Is that okay? Now let me give some hint for this given graph. Oriented graph means the direction should be given. Direction if not given, you can consider however you want. Okay, from a given graph I'll be giving some hint. How many the network consists of, this network consists of 4 nodes. Yes or no? Bus is nothing but it is a node. This is one node, second node, third node, fourth node. Total it is consisting of 4 nodes and 5 elements. So no, that is 4 nodes, n equal to 4 and e equal to 5. Fine. You should first, these are the preliminary steps, you should write it before solving the problem. The number of branches is b equal to n minus 1. You calculate, you will be getting 3. The number of basic loops is given by L equal to E minus N plus 1. If you substitute, you will be getting totally 2 links. First you should calculate number of links and number of branches. So totally there are 2 links. So how I should frame 2 links? I should draw a tree for a given graph. Let me draw a tree for a given oriented graph. Okay. This is node bus 2, bus 1, bus 3, bus 4. Okay. Now from 1 to 2, I named this as branch 1, branch 2, branch 3. Okay. I'll consider this branch 4 here from 1 to 2. See here, from 1 to 2 only it is connected, branch 4. Also from 2 to 4. From 2 to 4, there is one more branch, or it is a link, 5. Arrow mark is given in this direction. Is that okay? So I have drawn a tree also for a given graph. Calculate all these bus incidence matrices. Okay. Draw a tree for a given sample network. I have already drawn where solid line represents branch, dotted line represents link. Okay. So try to solve this. I have explained one problem, how to draw basic cut set matrix and basic loop incidence matrix, tree branch path incidence matrix. Also have explained how to draw element node incidence matrix A cap and reduced incidence matrix A. Okay. The same way, for a given tree, calculate all these bus incidence matrices. Is that okay? Some more hints I'll give. Write the matrix for A cap and write the matrix for A. You'll be getting some matrix like this. Split this into two components, AT and AL. Okay. And write the matrix for K. Here you'll be getting 1, 2, 3, and here it is 2, 3, 4 nodes. Okay. Here they will be assuming 1 as a reference node. In order to write B matrix, B is nothing but basic cut set incidence matrix. Again you will be writing some matrix. Split this matrix into two components, BT Twix and BL links. But from basic consent matrix we know that BL matrix multiplied with the AT matrix equal to AL matrix. This you need to prove in the basic cut set matrix. After you write this basic cut set matrix, try to prove this expression. BL is nothing but this one, BL matrix into AT matrix. If you multiply this BL into AT, sure you will be getting AL matrix. This cross check it. Okay. Next, augmented cut set matrix. It is represented as B cap. The format for this matrix is IT. Here it is 0. Here it is BL. And here it is IL. So this is the entire matrix. You should fill this matrix such that IT means it is identity matrix with the size T 1 1 1. Here also it is 1 1. Fine. 0 0 0 0 0 0. I should divide this matrix into 4 components, 4 partition. Here it is 0 means 0 0 0 0 0 0. Here it is BL. BL already you have got. This matrix you need to substitute over here. Okay. The same way you calculate C matrix. C matrix means it is basic loop incidence matrix C. Again you will be getting this matrix. You will be splitting up in this matrix into CB divided by CL. Split this matrix. Branches and links you will be differentiating. Also you will be specifically writing this C cap matrix into 4 components here again. Here it is CT, IT, IL, and here you will be getting 0 matrix. Yes or no? So these are the hints I have given in order to solve this given problem. We'll continue with the third problem. Okay. form the primitive impedance matrix and primitive admittance matrix. Okay, now given element Z impedance in per unit, mutual impedance, elements 1, 2, 3, they have given 3 elements corresponding for the first element impedance is j.6, j.5, j.7. Mutual impedance they have not given, only for element 2 they have given j.2 with element 1 they have given. Okay, now solution. They have asked us to form a primitive impedance matrix. Primitive impedance matrix means it is Z, where Z11, Z12, Z22, Z33, Z12, Z13, Z21, Z23, Z31, Z32. So this is a primitive impedance matrix. They have asked us to form primitive impedance matrix and primitive admittance matrix. Admittance matrix means it is Y. Y means we know that it is 1 by Z. 1 by Z, or it is impedance matrix inverse. So how to fill this Z matrix? Z matrix equal to 1, 2, 3, 1, 2, 3. Now Z11 means the impedance what they have given, this is Z11, j.6. This is not having any mutual relation or mutual impedance with the other elements. So here it is Z22. It is Z33. Okay. Now they have told for element 2 j.5. Okay. J.5 means it is Z22. Here they have given j.2. This is a mutual impedance with, this is second element here and here. This is having mutual relation with element 1, means Z, see here, element 2 value with element 1. Okay, element 2 value with element 1. These are the two components where they have told j.2. It is j.2 with element 1. Okay, now here also it is j.2 second element with element 1. So Z12 and Z21 both are same. That's why they have said mutual impedance with element 1. Whereas for 3, nowhere they have mentioned j.8 or 0.7 anything with element 1. If they have mentioned with element 1, then here these two parameters will be filled by that particular given mutual impedance. Nothing they have given just dash, means no impedance. Here also it is 0, here also it is 0, 0, 0. Understood? So once after you get this Z matrix, in a calculate primitive admittance matrix Y equal to 1 by Z or Z inverse. Calculate this. I'll be writing directly answer. Cross check whether you'll get minus j 1.9231, j.7692, 0, 0, 0, j.7692. Both this Z12 and Z21 is same, because see here Z12 and Z21 both are having the same impedance. So here also you'll be getting the same value. minus 2.3077 and here 0, it is minus J 1.4286. Okay, in today's session we have discussed totally 3 problems. Practice this all the problems and come prepared for the next class. Hope you all are understanding these problems. Okay, fine. Thank you.